Is the planet Mars dead or is it only sleeping? This is by Bill Steigerwald, NASA Goddard Space Flight Center. Concerning the geology of Mars. The surface of Mars is completely hostile to life as we know it now. Martian deserts are blasted by radiation from the sun in space, and the air is so thin, cold, and dry. If liquid water were present on the surface, it would freeze and boil at the same time. But there is evidence, like vast, dried up riverbeds, that Mars was once a warm and wet world that could have supported life. Are the best times over, at least for life on Mars? Is a question. New research raises the possibility that Mars could awaken from within. 3 large Martian volcanoes may only be dormant, not extinct. Volcanic eruptions release lots of greenhouse gases like carbon dioxide into the atmosphere. If the eruptions are not complete, the future eruptions large enough, they could warm the Martian climate from its present extremely cold and dry state. NASA-funded researchers trace the flow of molten rock magma beneath the 3 large Martian volcanoes by comparing their surface features to those found on Hawaiian volcanoes. And we have here the picture of the big circle, Olympus Mons, and the 3 other smaller volcanoes in a line under it, almost forming a triangular volcanic system. Arsia Mons on the bottom, and Pavonis Mons in the middle, and Acreus Mons at the end. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Now, on Earth, the Hawaiian Islands were built from volcanoes that erupted as the Earth's crust slid over a hotspot, a plume of rising magma, said Dr. Jacob Bleacher of Arizona State University at NASA's Goddard Space Flight Center in Greenville, Maryland. He said, "Our research raises the possibility that the opposite happens on Mars. A plume might move beneath stationary crust. The observations could also indicate that the 3 Martian volcanoes might not be extinct." Bleacher is lead author of the paper on the results that appeared in the Journal of Geophysical Research in Planets. Now, these 3 volcanoes are in the Tharsis region of Mars. They're huge compared to our terrestrial volcanoes, with each about 300 kilometers, that's 186 miles across. They form a chain heading northeast called the Tharsis Montes, from Arsia Mons, just south of the Martian equator, to Pavonis Mons at the equator, to Asclepius Mons, slightly more than 10 degrees north of the equator. No volcanic activity has been observed at the Tharsis Montes, but the scarcity of large impact craters in the region indicates that they erupted relatively recently in Martian history. Features in lava flows around the Tharsis Montes reveal that later eruptions from large cracks or rift zones on the sides of these volcanoes might have started at Arsia Mons and moved northeast up the chain, according to the new research. The researchers first studied lava flows, features that are related to the eruptive history of Hawaiian volcanoes. On Hawaii, the Big Island, the youngest volcanoes are on the southeastern end, directly over the hotspot. As the Pacific crustal plate slowly moves to the northwest, the volcanoes are carried away from hotspot, and over time, the movement has created a chain of islands made from extinct volcanoes. Volcanoes over the hotspot have the hottest lava. Its high temperature allows it to flow freely, and a steady supply of magma from the hotspot means the eruptions last longer. Lengthy eruptions from lava tubes as the surface of the lava flow cools and crusts over, while lava continues to flow beneath. And after the eruption, the tube empties and the surface collapses, revealing the hidden tube. As the volcano is carried away from the hotspot, magma has to travel farther to reach it, and magma cools. Cooler magma makes the lava flow more slowly compared to lava at the younger volcanoes, like the way molasses flows more slowly than water. The supply of magma is not as steady and the eruptions are shorter. Brief eruptions of slowly flowing lava form channels instead of tubes. Flows with channels partially or completely cover the earlier flows with tubes. As the volcanoes move even further from the hotspot, only isolated pockets of rising magma remain, and as the magma cools, it releases trapped gas. This creates short explosive eruptions of cinders, gas bubbles out of the lava, forming sponge-like cinder stones, and earlier flows become covered with piles of cinders called cinder cones, which form around these eruptions. We thought we could take what we learned about lava flow features in Hawaiian volcanoes and apply it to Martian volcanoes to reveal their history, said Bleacher. The problem was that until recently there were no photos with sufficient detail over large surfaces areas to reveal these features on Martian volcanoes. We finally have pictures with enough detail from the latest missions to Mars, including NASA's Mars Odyssey and Mars Global Surveyor, and the European Space Agency's Mars Express missions. Using images and data from these missions, the team discovered that the main flanks of the Tharsis Montes volcanoes were all alike, with lava channels covering the few visible lava tubes. However, each volcano experienced a later eruption that behaved differently. Lava issued from cracks and rifts on the sides of the volcanoes, forming large lava aprons called rift aprons by the team. The new observations show that the rift apron on the northmost volcano, Acreus Mons, has the most tubes, many of which are not buried by lava channels. Since tube flows are the first to form over a hot spot, this indicates that Acreus was likely active more recently. The flow on the southernmost volcano, Arsia Mons, has the least tubes, indicating that its rift aprons are older. Also, the team saw more channel flows partially burying tube flows at Arsia. These trends across the volcanic chain indicate that the rift aprons might have shared a common source like the Hawaiian volcanoes, and that apron eruptions started at Arsia, then moved northward, burying the earlier tube flows at Arsia with channel flows. Since there is no evidence for widespread crustal plate movement on Mars, one explanation is that the magma plume could have moved beneath the Tharsis Mons volcanoes, according to the team. This is possible to the opposite the situation in Hawaii, where volcanoes move over the plume that's either stationary or moving much more slowly. Another scenario that could explain the feature is a stationary plume that spreads out as it nears the surface, like smoke hitting a ceiling. The plume could have remained under Arsia and spread northward towards Acreus. Our evidence does not favor either scenario, but one way to explain the trends was to see if the plume moved under the stationary Martian crust, said Bleacher. The team also did not see any cinder cone features on any of the Tharsis Montes rift apron flows. Since cinder cone eruptions are the final stage of hotspot volcanoes, the rift apron eruptions might only be dormant, not extinct, according to the team. If the eruptions are not complete and future eruptions are large enough, they could contribute significant amounts of water and carbon dioxide to the Martian atmosphere. And this was by Bill Steigerwald, NASA Goddard Space Flight Center, on phys.org. Please leave your comments, and thank you for your support. In other words, the conclusion is they probably are not extinct volcanoes.